Greetings of the day, dear students. In this video, we are going to discuss about the circuit breaker and what are the main types of circuit breakers like MCB, miniature circuit breaker, earth leakage circuit breaker, ELCB, air blast circuit breaker, molded case circuit breaker, MCCB, vacuum circuit breaker and SF6 circuit breaker. And also in detail we will go or discuss about the miniature circuit breaker MCB, its a diagram, working principle, operation, and also we will see the what are the advantages we are having with respect to the MCB. In the previous video we have seen or discussed about the fuse element, right? And there we have discussed the different types of fuses. Similarly, here we are going to discuss about the one more switchgear component, that is the circuit breaker, right? Which is a switching device which will be operated manually or automatically for the control and protection of the electric power system. As long as the system is under normal working condition, the equipments are going to draw the rated currents, right? But during any abnormal condition arises, like any short circuit condition or any fault or any open circuit conditions or something such things, like if any abnormal condition arises, right, then the electrical equipment is going to undergo heavy stress because of the fault current, and now this fault current is going to damage the equipment and the networks permanently. So in order to protect the equipment, right, from short circuit currents or overload currents or any fault conditions, they are to be protected. In order to protect that, this circuit breaker will be helpful, right? Now its role is not only to clear the fault, right? Once the fault current is cleared, the circuit should be brought back to its normal operating condition as quickly as possible. If you observe, if it is with respect to the fuse, it can only make the break the circuit. During abnormal or fault condition, it can only just isolate the circuit, but it cannot make the connection again. Between the source and the load. So here this circuit breaker not only breaks the circuit, but it will also make the circuit. Right? Now here this circuit breaker is going to consist of it is going to have a fixed part and a moving contacts, which are called the electrodes. We are going to have a fixed contact and moving contact called electrodes, right? Under normal operating condition, these contacts will be remain closed and will not open automatically until and unless, right, the system becomes faulty. If any fault occurs, then only these contacts will be opened, right? Now the contacts can be opened manually or by remote control whenever it is desired, right? So when a fault occurs in any part of the system, the trip coil present in the circuit breaker will get energized and the moving contacts will be pulled apart by some mechanism. Thus, because of that, the circuit will get opened. So here the trip coil will get energized during abnormal or fault conditions, and the moving contacts will be pulled apart by some mechanism. If we come across the different types of circuit breakers, we are having MCB, miniature circuit breaker, earth leakage circuit breaker, air blast circuit breaker, molded case circuit breaker, vacuum circuit breaker and SF6 circuit breaker. Now in this video we are going to discuss about the miniature circuit breaker. Now this miniature circuit breaker is an electromechanical device which is going to protect the electrical circuits from the over currents. If any over currents are going to arise due to fault, right, then the equipment will get protected with the help of MCB, right. Now these overcurrents are arised due to short circuit conditions, or due to any overload conditions, or due to some faulty design. So three possibilities are there: due to due to occurrence of any fault, right, or due to occurrence of any overload condition, or due to occurrence of any short circuit conditions, the overcurrents may result in the electrical circuit, right. So here the MCB will be act like an alternative. It is a better alternative to the fuse, because it does not require the replacement once an overload is detected. If it is the fuse, once the circuit is broken, right, or once the circuit is got opened, in order to make the connection, establish the connection again, the fuse wire is to be wound. We have to attend manually, and we have to make the connection. But that is not the case with the help of MCB, miniature circuit breaker, right. Now this MCB functions. How it functions? It functions by the continuity of the electric flow, by interrupting the continuity of the electric flow through the circuit once the fault is detected, right. It will not allow the high amounts of currents to pass to the loads, right. So here the MCBs are designed to protect against the overcurrents and over temperature faults. So this is the diagram for MCB, right. It is going to have a solenoid, it is going to have an operating knob, and it will have a fixed contact. This is the fixed contact, and we will have a moving contact, and we used to have a bimetallic strip like this. These are the different components present in the MCB. Right. Coming to its working principle, as we have discussed earlier, there will be two contacts. One is the fixed contact, and another one is the movable contact. So whenever the current exceeds the limit, the solenoid forces the movable contacts to be opened, right, and the MCB will get turned off, thereby stopping the current from flowing into the circuits, right, because of these two contacts. One is the fixed contact and another one is the movable contact. Whenever any abnormal condition arises, and if the current is going to cross the limits, right, then the solenoid will force the moving contact to open. The solenoid will force the movable contact to open, right. It is going to consist of one bimetallic strip also, and it is consisting of one trip coil and one hand operated on off lever. To make it on and off, we used to have one hand operated on off lever, right. Now the path of current flow in MCB will be as follows, right. First it will pass through the left hand side power terminal, then it will pass into the bimetallic strip, then current coil, then through moving contact, then through fixed contact, and lastly through the right hand side power terminal. All these will be arranged in series. All these components like left hand side power terminal, bimetallic strip, current coil, moving contact, fixed contact, and right hand side power terminal, all will be arranged in series. This will be the order of flow of current in a circuit breaker. Now if the circuit is overloaded for a long time, now this bimetallic strip will become overheated and it will be deformed, right. Now the moving contact of MCB will be so arranged by means of the spring. With this latch point, there will be the little displacement in the latch, which will cause the release of the spring and makes the moving contact to move, and which will makes the moving contact to move for opening the MCB with the help of the spring mechanism, right, and this bimetallic strip, right, it gets operated, and it will during abnormal conditions it will make the circuit get opened. The current coil or trip coil placed in such a manner during the short circuit faults that the magnetomotive force of the coil will cause the plunger to hit the same latch point and forces the latch to be displaced. If any abnormal conditions will be there due to the magnetic motor force, MMF of the coil, right, the latch will get displaced. So this is the operation. So here again, when operating level of MCB is operated by hand, that means when we make the MCB at off position manually, the same latch will be displaced. As a result, moving contacts will get separated from the fixed contact in the same manner. Not only during the abnormal condition, if due to some sake of maintenance or some other purposes, if you want to break the circuit, or if you want to make it off, right, you can make it, you can operate it manually also. Right. Here whenever maybe the operation mechanism may be due to either it can be due to the deformation of the bimetallic strip, or due to the increased magnetomotive force of the trip coil, or due to the manual operation, right, the same latch will be displaced and will deform the spring, right, which is ultimately responsible for the movement of the moving contact. Now the moving contact can be moved either because of any one of these things, either because of the deformation of the bimetallic strip, or due to increased MMF of the trip coil, or due to the manual operation. So because of any one of these operations, the moving contacts can be moved. Once the moving contacts are moved, with the help of that you can make the circuit on and off, right. So when the moving contacts is separated from the fixed contact, there will be the chance of high arc produced in between those two contacts. Now that arc is to be extinguished, or that arc is to be eliminated. Because of sudden opening of the circuit, it will result in a arc between the contacts. Now that arc is to be quenched, or it is to be extinguished. That is also to be taken care by the circuit breaker. But whereas in fuse, if you observe, while discussing about the fuse element, there is a powder element where it is going to extinguish the arc, right? Yeah. Now this MCBs will be available in either single pole or double pole or triple pole, and 4-pole versions with neutral pole if it is required. Coming to the current ratings, they will be in the range of some 0.5 to 63 amps, right, with a symmetrical short circuits rupturing capacity of 3 to 10 kiloamperes at a voltage level of 230 to 440 volts. Now this MCBs will be designed to get tripped within 2.5 milliseconds whenever a fault current arises, right. In case of temperature rise or overheating, sometimes it will take some 2 seconds to 2 minutes for the MCB to get tripped. These are the ratings and specifications with respect to the MCB. Coming to its advantages, MCBs are replacing the rewirable switch or fuses units for low power domestic and industrial applications, right, where the power requirement for low power domestic and industrial applications, instead of using a rewirable fuse, it is better to go for a MCB, because it is going to not only break the circuit, but also it is going to make the circuit. Once the fault is cleared, automatically the circuit will be made into on position. Right. Now the disadvantages of the fuses, like low short circuit interrupting capacity, it is going to interrupt only up to 3 kiloamps, right, and also it is to be the connection is to be made manually. If it is fuse, the connection is to be established again manually, but that is not the case with the help of circuit breaker, right. So MCB is a combination of all 3 functions in a wiring system, like switching, overload and short circuit protection. It is also going to protect, and it is also going to act like a switch, right. Now the overload protection can be obtained by using a bimetallic strips, whereas short circuit protection can be obtained by using a solenoid, right? So these are the some of the important points with respect to the miniature circuit breaker, right? Thank you.